What if the entire universe, everything you've ever known, is trapped inside the most extreme object in existence? It sounds like fiction, but it's a serious scientific question. It suggests that the origin of our universe, the Big Bang itself, is actually the birth of a black hole in another, much larger parent universe. What if we're living inside a black hole? So today, we're going on a journey to the edge of science to explore the evidence, the implications. What was the Big Bang? Our standard model of cosmology tells us that our universe exploded into existence from a point of infinite density and temperature, a singularity, and the profound possibility that our cosmos is a prison from which we can never escape. This isn't just a random thought experiment. It's a compelling, though controversial, hypothesis known as black hole cosmology. At the center of this new black hole, matter continues to crush downwards, forming a singularity. But here is where the theory takes a crucial turn. The idea attempts to solve some of the deepest, most persistent mysteries in physics. It challenges our very definition of reality and our place within the cosmos. Instead, the quantum mechanical property of particle spin creates an incredibly powerful repulsive force called torsion. It happens within the confines of the black hole's event horizon. Our expanding universe is, in this model, the interior of a black hole that exists in another cosmos. It provides a cause for the Big Bang, wrapping the mystery of our origin inside a known physical process. The violent, swirling, and chaotic environment inside a forming black hole would stretch and twist space-time so intensely that any universe born within it would be naturally flattened out. The geometry of our universe could be a direct consequence of the extreme gravitational conditions of its birth. It also addresses another cosmic puzzle, the homogeneity of our universe. The cosmic microwave background, the afterglow of the Big Bang, is almost perfectly uniform in all directions. It would be a fractal, a potentially infinite Russian doll structure. Every black hole in our own universe could be the seed for a new baby universe, with its own Big Bang and its own set of physical constants. The biggest criticism is that the hypothesis is, at its core, untestable and unfalsifiable. While mathematically sound, this is a modification of Einstein's general relativity. The vast majority of cosmological observations we have are perfectly explained by standard general relativity. So introducing a more complex, modified theory is a significant theoretical leap that many physicists are hesitant to take without more direct evidence. Since we can never observe the parent universe, we have no way of gathering direct evidence to prove or disprove the theory. It's a compelling story that fits some of the data, but it might forever remain beyond the reach of our telescopes. It transforms black holes from objects of pure destruction into cosmic wombs, engines of creation. It provides a physical narrative for our own beginning and suggests that we are part of a vast, interconnected, and self-propagating cosmos. The black hole model suggests this is because the matter that formed our universe was violently mixed together during the collapse. But also, what if they are the gateway to another reality? And what if we are already inside one? For now, it is a beautiful hypothesis that reminds us just how much we still have to learn about the true nature of our reality. This torsion force halts the collapse and causes the matter to rebound in a big bounce. It just pushes the question back one level. If our universe was created by a black hole in a parent universe, where did that parent universe come from? And the one before that? It presents a potentially infinite regress of turtles all the way down problem that leaves the ultimate question of existence unanswered. Why does time in our universe seem to move in only one direction? The flow from past to future feels fundamental, but many laws of physics work just as well forwards as they do backwards. This theory provides a simple, intuitive answer. Time has a direction because our universe is flowing or falling towards the singularity of the parent black hole. The biggest one is the flatness problem. It's a point where our laws of physics, including Einstein's general relativity, simply break down and stop making sense. The event horizon of our parent black hole is our cosmic horizon. It's the boundary of our observable universe. We can never leave, and we can never receive any information from the parent universe outside. We are fundamentally isolated. If the universe had even slightly more energy and matter, it would be closed like a sphere and would have eventually collapsed back on itself. The standard cosmological model explains this incredible flatness by proposing a period of cosmic inflation, a moment just after the Big Bang where the universe expanded exponentially fast, smoothing out any curvature. It paints a picture of a universe that is constantly recycling and reproducing itself through the birth and death of stars. Inflation works mathematically, but it's an add-on, a special ingredient we need to make the theory match reality. If it had slightly less, it would be open like a saddle and would have expanded too fast for galaxies to form. The theory tells us what happened a fraction of a second after the Big Bang, but it says nothing about the cause. To understand this radical idea, we first need to appreciate the problem it's trying to solve, the ultimate cosmic mystery. But this explanation is deeply unsatisfying to physicists. A singularity isn't a physical object. It's a mathematical error message. What ignited the explosion? What came before it? The Standard Model offers a wall of silence. This has forced scientists to look for alternative models that can provide a physical origin story for our universe. And this is where the black hole comes in. Within this cosmos, a supermassive star, many times the size of our Sun, reaches the end of its life. It runs out of fuel, and its core collapses under its own immense gravity. Because the universe has another famous type of singularity, the one lurking at the heart of every black hole. The theory, championed by physicists like Nikodem Pawłowski, proposes a natural physical process. It begins in a hypothetical, much larger parent universe. This collapse is so catastrophic that it forms a black hole. An object with a gravitational pull so strong that nothing, not even light, can escape once it crosses the boundary we call the event horizon. Using a modified version of Einstein's theory called the Einstein-Cartan theory, Pawłowski argues that the singularity never reaches a point of infinite density. This bounce, an explosion of unimaginable energy and matter, is what we perceive as our Big Bang. Now, this might sound like a convenient story, but the hypothesis is compelling because it naturally explains several observed properties of our universe that otherwise require special, fine-tuned explanations. Our universe, on a very large scale, appears to be geometrically flat. This is a very specific condition. Our universe is balanced on a knife's edge. Black hole cosmology, however, might solve the flatness problem naturally. Then there's the arrow of time. This creates a clear temporal gradient, a one-way street for causality that we experience as the arrow of time. So if we are living inside a black hole, what does that actually mean for us? First, it means we are trapped permanently. Second, it completely reframes the concept of a multiverse. It wouldn't just be a collection of parallel bubble universes, and in turn, our entire universe could be just one of many, nested inside a black hole within an even larger cosmos, and so on, forever. However, as elegant as this idea is, it remains on the fringes of theoretical physics for several very good reasons. Furthermore, the most robust versions of the theory rely on the Einstein-Cartan theory of gravity. Finally, the theory doesn't solve the ultimate origin problem. So, while we cannot say for sure that we are living inside a black hole, the possibility remains a powerful and thought-provoking idea. It's a testament to our relentless curiosity that we can look out at the stars and not only ask, "What are they?"